Hello farmers, welcome to PipeFlux app. Today we are going to know what is PipeFlux actually, what it does, how it does, and how it will be useful for you. So PipeFlux app is basically designed to simplify the pipeline engineering concept and the calculations. So it is useful for the farmers, the personnel working in pipeline industry, in sales of pipeline, the dealers of pipes, the hardware merchant, the civil engineers. So we are trying to make it more useful for many of the pipeline related working professionals. So PipeFlux is basically designed to do some complex calculations like velocity of the water traveling in the pipe, selection of proper diameter of the pipe, proper class of the pipe. Class stands for the pressure rating of the pipe. Um, the head loss calculations due to friction, head loss due to friction calculations, also the total head requirements for the entire pipeline system, as well as it calculates uh, the pumping capacity required, and also as a additional as a bonus to all of you our users, we are providing the water hammer calculations as well. So let's start to see actually how the application works. Currently we are in process of developing, still we are fixing some bugs and some errors, some minor changes, graphical changes we are still doing that. So since we are uploading the application, we are supposed to have some links, so we are in hurry to make this explanatory and guiding videos for you and upload it to YouTube. So we link them in our app. So there are some minor graphical changes you may see in our app icons and some graphics. So apologies for that, because still we are improving our application. So this will be the application logo. You may find slightly different than the way it is seen, but you can see it will be a P like logo, which is seen in the current screen. So let's open and see how the app is designed. So you can see there are basic tabs which we are giving here. There is first is calculation checklist, second is calculate. The way I said that we are still in process, so you cannot see a graphical image on calculate tab. Soon it will be fixed. Then there is some installation guide and related videos. Then we are having some selection of pipeline devices, pipeline protection devices, which will be very essential to save our pipeline from bursting and other kind of failures. Then there is another tab for contacting engineers behind this application calculations. Also there is a references and disclaimer, which is explaining the references where we got the calculations of this application from. So let's see the one by one. We go for the calculation checklist. We open it. There is some another sub tabs, data needed for pipeline calculation. So this tab is something like what you need to do some calculations. There is a required flow of water in per liters per hour. So this is the amount of water actually you need to push through the pipeline. You need to know how much water you needed, and we are very specific on the units. In future updates we will be giving you the flexibility to select the whatever unit you want. So still we are trying to provide you a MVP, that is minimum viable product, so that you appreciate us. Then we will be doing some further more calculations. The second part which we need to do the pipeline calculation is length of the proposed pipeline in meter. So app length finder app link is provided in this app. You can follow the next video to find out how to get these parameters of length of the pipeline. The third one is elevation difference. The following this video, the third video will be explaining how to find the elevation difference. Elevation difference is nothing but the difference in the level of 2 points where the pumping starts, or where the pipeline starts and where the pipeline ends. It's a difference in height actually. So we need to know that one also. Suction depth in meters. So the where the suction depth is the where the your pump is sitting. From there, the lowest water level where you are sucking from, maybe either it is reservoir or it is from river. So lowest water level where your pump need to suck from, that is the suction depth. It is belongs to only the surface pumps. If you are using a submerged pumps, submersible pumps, like those pumps which are not having any suction pipes, they are already submerged in the pump and submerged in the water, and they just suck the water through around the pump. So this concept is only for those pumps which are installed on the ground. Wall thickness of pipe. Wall thickness of pipe is nothing but the difference in outside diameter and inside diameter. This wall thickness chart for the particular diameter of the pipe and particular class, that is pressure rating of the pipe, we have provided in the app. We have considered currently for the two standard systems, that is Indian standards and another one is South African standard. So both are the wall thickness information according to pipe sizes, and the pressure ratings are given. You can select it from there. Now with this all data, you should record it somewhere, so that which will be needed for further calculations. This guideline on the pipe wall thickness, that's what we have decided, that it is Indian standard. You can see there is any class of pipe you can consider. If it is 200 and if it is a class 4 pipe, then the wall thickness should be 4.6 So this is how we are going to find the wall thickness. It is also provided in the calculation list also. This find elevation and length app I have provided. There is a link in this table which directs you to elevation calculator, my elevation, and there is another field area length app calculator where you go field area measure. So we are giving the links which directs to the some application which may help you finding some parameters which are needed for pipeline. How to use those apps, we have given the videos in subsequent playlist. There is a diagram for understanding. This diagram which shows you the entire components of the pipeline system, as well as how those components should be installed, and a general arrangement of pipeline, you can say. There is also a outside diameter, inside diameter, and wall thickness explaining diagram as well. So maybe this will be useful for for uh, for understanding the pipeline system. There is a video guide on how to use the app. This is the video which we are doing recording right now. So let's move on to the next tab, which is calculate. Now you can see there somewhere we have, this is the calculator. While we are using in some information on the field area measure, we have marked some points. So coming back to the calculator tab, you are going to know where we have marked in that another video. So pipeline from, it is a alphanumeric input. You have to just input where your actually pipeline starts. So we can say it is a Chikotra. It's a name of a river, Chikotra River. This is the pipeline starts, a starting point, and goes to the Bhairona temple. This is a delivery point we are selecting. This is a delivery location. It can be anything for you. Maybe pipeline from lake, pipeline from any well, or pipeline from so reservoir and going to some certain point. It's just a matter of putting the location names. Now the discharge in LPH. What discharge you are looking for this while designing this pipeline? Somebody may need whatever, so we consider currently for the discharge needed is 30,000 liters per hour. So length of the pipeline, we some in other app using the field area measure or elevation, the field area measure app, we have find out how much is the length required to travel from this pipeline from pipeline 2. This length between these 2 points is what we have calculated, that it is 1.6 kilometer, is nothing but 1600 meters. So outside diameter, we can just make an approximation for the calculation purpose, how much diameter of the pipeline we are going to need. So this is 30,000 liters per hour. So consider 110 outside diameter pipeline we are going to need, and the pipe class, pressure rating of the pipe, it is the class of the pipe. Suppose we are going to need a 4 kg pipe, so we write as a 4. So now we need to know the wall thickness of the pipe. Now 110 and class 4 pipe, what is the wall thickness? If you look at the Indian standard, the 110 pipe and class 4 is having 2.5 of wall thickness. So this wall thickness we have to write in our required tab. It's 2.5 when you see, if you input, when you input the wall thickness, the inside diameter of the pipe is auto calculated. It's 0.106 meters. It has calculated in meter, that's why it is coming 0.106. Now you see velocity of water in seconds, it's 0.9, and you can see there is some popping up in a green button. It's a safe velocity. That means this calculations is giving us safe velocity. Now consider if we are having some different diameters. Let's check with 90 okay, because the 0.9 and with 110 the velocity is coming 0.9. So we are trying to change the diameter so that we can save some money. So we have to check 90 class 4. What is the wall thickness? 90 class 4 is 2.1. okay, 2.1. So we write our wall thickness as a 2.1, and as we change, the velocity is changing to 1.4, you can see, but still it is in the safe velocity. Now which one we are going to select? Now how we are going to select? We are going to decide from head loss due to friction. Now you can see when we selected 90 pipe, the head loss due to friction is coming 38.2 meters, and when we selected 110, let's select 110 and let's see what are the outputs coming. 110, wall thickness was 0.5. So when we selected, you see the wall thickness is 2.5. Once you input, the velocity is reduced, and head loss is also reduced, 13.8. So with increasing a little bit of pipe diameter, head loss due to friction is drastically reduced. So we recommend that we should go for 110 because the head loss due to friction is less. That means the pumping capacity which you are going to need is less again. So now we have to check for the delivery head. We have, in a subsequent video we have told how to check this delivery head. You can see, use my elevation app, and if you know perfectly what the elevation difference is, you can write in the meters. So I know somewhere 21 meters is the elevation difference between those two locations which we said in the start of this tab. So we write as a 21 meter. Suction head, I know it's 2 meters, uh, where the pump sitting, and the lowest water level is 2 meters. So head required to operate the, I want to install a drip irrigation system on this very same pipeline. So I may select 15 meters as a irrigation system operating head. You can see there are some uh, different heads also. You can see if it is drip is 15 meters, generally sprinkler if it is 15 to 25 meter, depend on which kind of sprinklers you are using, and if it is a furrow irrigation, it can be 5 meters is enough. So let's consider it is a drip irrigation. So we need as a 15 meters of head. So when you input that, you are going to get the total required head to run this system is 57 meter. Now you see pump capacity is also auto calculated. It's 9 HP pump needed. Now this is that pump HP is calculated 70% overall efficiency. This may be 10 HP or maybe 7.5 HP. You can just go with this. When you are buying the pump, you can go with this maximum head which is needed in your system is 57 meters, and the flow, this is the 30,000 liters per hour. Maybe the pump manufacturer have some more efficient pumps which can be less than 9 HP, but this is the indicative calculation for you to know where we are going actually. Now water hammer is the bonus part for our users we are giving. We have struggled a lot to find these calculations. Anyways, we have done it for our users. What we need is water hammer actually. What is water hammer? Whenever the pump gets tripped, the water tends to come back. Tripping of pump may be due to power failure or any electrical failure in the panel of the pump, or any breakdowns. The if pump stops suddenly, the check valve get closed on the delivery, and the moving water in the pipeline tends to come back with the gravitational force, even with the more pressure. So it creates a pressure spike, which we are trying to calculate over here. We need to know the valve closure duration in seconds. If you are knowing, that's perfect. If you are not knowing, you can use one as an indicative value, so that you can imagine how much water can be generated. Now since the water the valve closure time we don't know, this figure may slightly differ, but it can give you indication that what may happen in your pipeline. So maximum head can generate due to water hammer is 79 meters. That is nothing but 8 bars, and the total operating pressure of the pipeline is 57 meters. While our pipeline we have selected is class 4 pipe. So 57 meter is nothing but class 6, or 6 kg per centimeter square pressure rating is needed, not the 4 kg. So we have to change this to 6 kg per centimeter square pipeline, or we have to increase some diameter. But if we increase the diameter of pipe, the velocity will reduce, and too much less velocity will cause also some siltation problems inside the pipeline. So it's better to use some class 6 pipes, or reduce some discharge. That you are going to decide from your practical availabilities and needs. So this calculation part we have done in the application. Also there is some installation guide and related videos. There are many points we have covered, like ideal installation diagram, how to find the requirement of pipeline, selection of pumping site. All the pipeline related points we have covered in detail in this application. Also, there is a some device list which can save your pipelines, and which are very essential to have a trouble-free pipeline system. You can check one by one. If you want some personalized services for your pipeline and projects, then you can still contact to the engineers through this tab provided. It's very easy to get in touch with the engineers. Just don't forget to mention about your details, like a name and your email address and contact number, while you are getting in touch with the engineers, so that they will get back to you in time. There is a references and disclaimer where we have explained where we have derived the formulas to calculate this applications calculate tab, and there is a disclaimer about such kind of things, where wall close, like we discussed in water hammer, which is, we don't know the exact uh, exact wall closure time. So such kind of times, the application may give some figures which not match with the with the practical scenario. So we have no liability towards such kind of damages or loss incurred due to for due to incomplete information provided to the application for some calculation. So this is all about PipeFlux app. We will be adding in future, we will be adding some more features in this application, subject to your support. So we request you to download, share with your friends, let everybody have this thing in their hands. Thank you very much.